I'm going to be talking to University of Calgary geoscience researchers, Dr. David Eaton and Dr. Thomas Eyre. They're part of a team that have discovered evidence of two slow slip earthquakes in northeastern British Columbia, appear to be correlated with hydraulic fracturing. So that's a controversial oil and gas production technique. So welcome to the interview, gentlemen.
Thank you. Glad to be here.
Thomas, let's start off with you. Could you give us an overview of the study, please?
Yeah, so we were approached by some scientists from Natural Resources Canada. Their focus is on using satellite radar data, so interferometric synthetic aperture radar. And basically they've been mapping things like landslides in northeastern BC, but they came across these really unusual signals, which appeared to look like earthquakes. And so they looked inside into an earthquake catalog for the area, but couldn't find any evidence of an earthquake taking place. So they came to us with this unusual signal, and we were trying to work out what could have caused this. And we came up with this hypothesis that it's likely a slow earthquake rather than your typical earthquakes where you'd expect some shaking to occur. And so when we looked into this in more detail, we found that there were two earthquakes that occurred, and they correlated perfectly in space and in time with hydraulic fracturing treatments that were taking place during these periods.
David, maybe you could explain for us what a slow earthquake is.
Well, a slow slip earthquake, it's something which has been discovered in the last few decades. It's characteristic of certain fault systems. And basically, it's an earthquake that just occurs, as the name suggests, with a really slow slip velocity. So the earthquake itself might last a few days, might even last a few weeks. Because the slip on the fault is happening slowly, it does not radiate damaging seismic wave energy in the same way that a conventional earthquake would.
And Thomas, what's the significance of this? If it's correlated with hydraulic fracturing, like normally when that evidence of that is picked up by seismographs, as I understand it, then there's a protocol, and the operation has to shut down or pause, and there's some investigation that follows. It's of some significance to local people. But what's the significance of a slow slip earthquake caused by fracking?
Well, so as you mentioned, obviously we know that hydraulic fracturing in some rare cases can cause your typical earthquakes. But in this case, because they're slow, it's actually probably a good thing in that they're releasing the energy without any shaking that's occurring. So although we get this deformation at depth, there's no shaking that's going to affect the local populations. However, we did show in a study a couple of years ago that if this deformation occurs, it can potentially lead to stressing further along the fault in areas where you might get earthquakes occurring. And so this is, although in this case we didn't get any larger or significant earthquakes occurring, I think this is kind of validation of that study where we have a case of slow slip occurring, whereas it was hypothesized in that paper. We didn't have any direct evidence, which we now have.
David, is the significance here, is the potential problem here that the slow slip earthquake then sets up the possibility of other hydraulic fracturing induced earthquakes that could be a problem?
Well, as Thomas mentioned, we've done some previous work where we hypothesize that when a slow slip is occurring, that it changes the stress conditions in the vicinity of the slow slip event. It could be moving some faults closer to failure. It could actually be releasing stress on some faults. So it's a complicated system that we need to understand better. I think what's really scientifically significant here is that when slow slip earthquakes occur in nature, and this adds to kind of the natural types of phenomenon that we're now seeing in relation to hydraulic fracturing and other types of fluid injection.
So Thomas, what's the next step here? Is there a next step in terms of your research around slow slip earthquakes and fracking?
Yeah, so in terms of my research, I think we're trying to better understand how we can use this kind of information to help with, for example, pre-operational risk assessments and things like that, and just better bringing that into our understanding of the hazard and the mitigation of those hazards. But for sure, this is an interesting breakthrough, and I think it's definitely worth pursuing for some future research into trying to see if this is just a one-off event or whether it's a more common phenomenon that we didn't really realize before.
So if I understand you correctly, if you do further research and you discover that this is more common, that when a company's planning a fracking operation, then they can take, with their own background research, they can take that into consideration. Is that what would happen?
Yeah, exactly. So obviously companies need to know that this kind of thing can occur, and can bring it into their kind of planning around their mitigation techniques, because as I mentioned, there is a possibility that a slow event like this could potentially be a source of releasing stress on the fault, which is, as I mentioned, good in a way that it's doing it without any shaking. But again, it could also lead to an actual induced earthquake, a more typical type that could cause shaking. And so they really need to get or understand how they can mitigate that.
If I could just quickly, quickly add one thing to that. I think another thing that's important here is we brought a new tool that can be used for investigating these things. So to date, it's been approached from a traditional seismological point of view. We have a network of seismic stations that we use to try to detect earthquakes. But if we can see these things from space with satellites, that brings a whole new tool to bear, this INSAR tool. And I think that's something that's going to be very exciting to look into in the future.
So has that not been used, David, that particular tool not been used to study induced earthquakes?
It has been used to a very limited extent to study induced earthquakes. It's been used with great success to look at the deformation patterns, ground deformation patterns for larger natural events. But I think where our paper really breaks new ground is that we're applying it to induced earthquakes, and we're applying it to a slow slip event that's part of an induced earthquake sequence. And so I think that really contributes to our fundamental understanding of how these systems work.
Well, gentlemen, thank you very much for your insights. Really appreciate it.
Thank you.
My pleasure. Thank you.